Hello, everyone. Thank you all for joining us today, and thank you to the workshop organizers for inviting me to deliver this talk. My name is Mohamed Khamis. I am an assistant professor at the University of Glasgow. I'll start by showing you this video. So what happens here is that a user enters a PIN on his mobile device. He interacts a bit, and then he leaves briefly to get coffee. And in the meantime, somebody comes in with a thermal camera and takes a thermal image of the phone's surface. And in this thermal image, you can see not only which digits the user has pressed, but also the order in which they were pressed, because the last pressed digit is actually the warmest one. So from that, you can infer the PIN and even the order of entry. And actually, you could buy a thermal camera from Amazon for less than 150 pounds. You can even get a voucher if you buy one. And once you have one, you can use it to perform such attacks that are, obviously invading other people's privacy and security. So the reason I'm bringing this up is that we are seeing more and more ubiquitous technologies that are becoming affordable and, easy to use to an extent that it allows untrained people to even use it to maliciously to invade people's privacy, as we've just seen in the video. And actually, another example of a ubiquitous technology that could be used maliciously is eye tracking. So now we have eye trackers, they are becoming more pervasive than before. We have them integrated in laptops today. There are a lot of open source libraries for accurate eye tracking using RGB cameras that are integrated in laptops and the ones we use for webcams and so on. Also, mobile devices are actually developing so fast, and now you have a lot of smartphones that come with depth cameras or depth front-facing cameras, and these are very good for eye tracking, actually. So there are already a lot of applications online of sample applications that use eye tracking or do eye tracking actually um, on mobile devices such as the iPhone and Huawei and Samsung phones, so the recent ones that come with front depth cameras. And if you look into research activities, you can find even more, examples of pervasive eye tracking. So this is work that we did back in 2017, where we wanted people to interact with large displays in public areas. And we thought that we could move the eye tracker to allow people to interact while they are moving in front of a display. And then we took it further in another fun project where we used a drone to detect gaze gestures to the left and to the right and communicating this to a display. And this is all exciting, and brings, interesting opportunities of interaction in public space. But then actually, do we want drones around us that are tracking our eyes? Similarly, if you look at mobile devices, you will see that there has been almost an exponential increase in the number of papers in the past years that propose using eye tracking, or they leverage eye tracking on mobile devices. The orange line over here shows papers that used eye tracking on unmodified mobile devices. So basically, just by installing an app, doing modifications on the software side. And that was even before the release of mobile phones that come with depth imaging, or at least depth imaging in the front-facing camera. So actually, we are starting to see more and more applications of eye tracking that are becoming more pervasive, that do not require additional hardware. And I agree that this is super exciting, but at the same time, it comes with privacy implications. So what are the privacy implications of eye tracking in the wild? What are similar things that could happen, things that are similar to the video that I showed you about thermal imaging? So if you look into research in psychology and other fields like neuroscience and so on, you can find that a lot of like a wide range of personal information can be inferred from gaze data. So, for example, some of the big 5 personality traits could be inferred from gaze behavior. You can detect emotional valence and cognitive states of users from their eye movements. You can also detect if a user is in a mind-wandering state. And probably the easiest thing you could do is that you could detect the visual interests of people using eye tracking. So actually, sorry, there was a paper from Liebling and Prybush, I hope I'm pronouncing their names correctly. It was from 2014 called Privacy Considerations for Pervasive Eye Tracking World. And they list a number of things that could be detected from eye movements. And some of them are really personal information. So some things are age, gender. You might not want to share them with the developer of a mobile app that uses eye tracking, but it seems that you can infer that from eye tracking data. You can even infer things like the affect and sexual preferences and hormonal cycles, which are really private things, and health, even like health issues. So this brings a lot of concerns, actually. And now, how could actually these attacks happen? So the users can be the victims. The users of eye tracking technologies could be the victims of these attacks. So when they're using eye tracking applications that are abusing the collected data, or they're collecting more gaze data than they need. So when I say data here, I'm referring to gaze data. For example, let's say a mobile application has access to the phone's camera and collect gaze data. And right now, there's no way to make sure the mobile app is using the collected data responsibly. If a mobile app allows the user to provide input using eye gaze, then it should actually just collect the information that allows interaction to happen and process it on the fly. The data should remain on the phone. It should not be sent to remote servers, for example, or it should not be stored beyond the duration in which it is needed. So it's important to also keep in mind here that people or developers might collect sensitive gaze data intentionally or unintentionally. So it could also happen unintentionally. They might, someone might just collect more data than they need, thinking that, okay, maybe it doesn't hurt. But actually, if you're sending this data to a remote server, if you're storing it on the phone, you're increasing the risk that someone might access it and infer private information about the user. Alternatively, what could happen is that the person that is using an eye tracker in a public area may actually infer personal information about people around them without their consent. So in an extreme example, imagine if I'm holding a mobile device that can track eyes, and I try to track the eyes of the person sitting next to me. And I can imagine that in the future you would be able to infer the private information that we've just looked at now in the previous slides. So if this was done previously on desktop computers, it'll tomorrow be done on mobile devices, or in the desktop computers or laptops that are being used outdoors, for example, or displays that are in public spaces and that are coupled with cameras for eye tracking. These could all be problems that happen. So this type of this category of threats are fueled by the ubiquity of eye trackers and the wide range of sensitive information that could be inferred from them. So what I'm encouraging the eye tracking in the wild community to consider are to ask these questions. So what are the privacy implications of eye tracking, and how can we make eye tracking privacy aware, and how can we ensure the ethical use of eye tracking? So my aim here is just to highlight that researchers need to address the privacy implications of eye tracking before it's too late. And when I say too late, I mean that by late, I mean that everyone has access to this technology and could use it in a bad or a good way. So this is a call out to the community that works in eye tracking in the wild to start putting these questions into consideration. And the last question I have here is, how can we protect the privacy of users and everyone in their tracking range? So there has been some efforts in this area, actually, and I'll show you a slide in a second about differential privacy and so on. And there's also a number of researchers from eye tracking, from legal studies and law, and people from companies as well that are interested in this. And if you'd like to get in touch with this consortium, I'm happy to introduce you. So I discussed these problems in two recent papers, one in Mobile HCI 2018 and the other in CHI 2020. So if you'd like to start looking into this area, I advise you to start by those papers where we discuss the privacy implications of eye tracking in some parts of them and what are ways forward to do them, to address them. And some of the very promising work from recent research in this area is the work on differential privacy in eye tracking, and that was in ETRA 2019. So these two papers looked into using differential privacy for eye tracking data. Differential privacy means basically the idea of, imagine you have a data set of eye tracking data from multiple people. What you want to do now is that you want to make sure that you're unable to track the data back to the user or to the person from which this data was collected. But at the same time, you do not want to limit the utility of the gaze data. So balancing this is challenging. The concept of differential privacy is common in security, and these papers were among the first to apply this on eye tracking data, and there's also positive. And I think we need to do more work like that. We need to look more into how to protect privacy because we want to really benefit and leverage the eye tracking technology and do all the great things that we can that can be done with eye tracking. But in order to leverage this, we need to really be careful about privacy and the ethical things that could go wrong if gaze data is not used responsibly. So I think it's our responsibility as researchers to tackle this and ensure that eye tracking can be used in an ethical way. So I know this all sounds dystopian so far. As I said, don't get me wrong. I'm here to encourage. I'm a proponent of eye tracking, actually, and I know that it enables a lot of amazing things. I consider myself an eye tracking researcher. And actually, also in this direction, I will actually now take a turn in the talk, and I'll tell you more now about how eye tracking can be used to improve privacy and security. So far I've been talking about how eye tracking as a threat to privacy, but then now can we actually use eye tracking to improve security and privacy? And the answer is yes, and there's actually a lot of interesting work in this area. So I think one of the earliest works in this area is the work by Kumar et al. Called iPassword, which in this work, it was published in the Symposium on Use of Privacy and Security in 2007. And basically, the idea was that you would enter passwords by using eye movements and dwell time to select keys on a on-screen keyboard. And the idea is that by doing this, it's harder for people around you to know what kind of password you're entering. So actually, security researchers were among the earliest adopters of eye tracking, and there has been actually there is a lot of earlier work than that about biometric authentication using eye gaze. So how to use eye movements to determine to distinguish users based on their unique eye movements. And actually, in the past couple of years, there has been an increasing use of eye tracking in security applications. So here, this is a figure that shows the number of papers published every year about eye tracking in security applications. And the blue ones are the ones that involve authentication. So authentication using eye gaze, be it biometric authentication or password-based authentication or knowledge-based authentication. So you can see that the vast majority is actually in gaze-based authentication, but there are also other categories, which I'll talk about in a bit, like privacy protection using eye gaze and also improving security based on gaze behavior. But the point I want to highlight here is that there has been an increasing use of eye tracking in security applications. And this is a positive thing. I think that there's a lot that could be done with eye tracking to improve security. So the following couple of slides are actually based on this paper called The Role of Eye Gaze in Security and Privacy Applications. Yeah, you can find more details there if you want to learn more about this. So we can roughly classify applications of eye tracking in security into three categories. There's authentication, there's privacy protection, and improving security based on gaze behavior. We can further split them to further categories, such as explicit authentication, where by this we mean like trying to intentionally move your eyes to provide a password. And there's implicit authentication or biometric authentication. I mean, another way to call it is biometric authentication. And there's the use of eye gaze to support multi-factor authentication. I'll speak in more details about explicit authentication today. And we'll also look a bit into privacy and so on. But actually, as I said earlier, there's a vast majority of the work done is in authentication, which is actually also, as I will say later, it's an opportunity for researchers to dig deeper and to look more into, how can we protect privacy using eye tracking and how can we improve security based on gaze behavior, because there is much less done in this area. And I think it's a shame because there's a lot of opportunities in there. So let's briefly talk about authentication first. So as I said, it could be split into these three categories. I'll talk about explicit authentication first. And now the nice thing about explicit authentication using eye gaze is that you could actually enter passwords using eye gaze in two ways. You could use eye gaze to enter what I call legacy passwords, or passwords that already password types that are already out there or that already exist. So for example, you use your eye movements to enter pins. And then there's gaze-based passwords where actually the password itself is composed of eye gaze movements. So let's see some examples. So on the left here, you see an example of a legacy password. So what happens here, the interface, this is a system called QAuth. What happens here is that the user is shown tiles or like keys similar to a pin pad. And then there is a moving digit in each of those boxes. And each one is moving in a unique way. And depending on how the user's eyes are moving, we correlate their eye movement to the movements of the objects on the screen. So basically, the user performs a smooth pursuit eye movement to follow one of these objects, and we compare this movement to the movement of the objects on the screen, and this tells us which object they're looking at. This way, actually, they're entering pins that at the end, they consist of digits, right? So they're only using gaze to select pins, basically. So the advantage of this concept is that, and any concept based, not just this system, this is just an example, but I mean the advantage of any gaze-based authentication system that uses legacy passwords is that it's very easy to integrate this into existing backends. So for example, let's say you have an ATM and you want to allow people to enter their pins using eye gaze, which would be a very good idea nowadays, actually, with the COVID-19 situation, because you don't want to touch the screen that has been touched by dozens of people before you. So imagine that you want to enter a password using eye gaze. What we need basically there is an eye tracker and basically just an interface. We just need to modify the interface basically. But at the end, the pin or the outcome, is what this system produces is a pin or a 4-digit pin, which could then be provided to the same backend. So you don't need to modify the backend of the ATM system or so. And that was the legacy type passwords. So the advantage is that they can be integrated easily, but a disadvantage, of course, is that people have to learn the mapping between the eye movements and the pins. So there are pros and cons. Now, the gaze-based passwords are the ones where the password itself consists of eye movements. And this is also very interesting because what you could do here in this example here, what happens is that the user enters a password on a mobile device that is composed of eye movements and touch input. So the user gazes to the left and then touches 1, then gazes to the right and then touches 4. So the password is left 1, right 4. It could be also different things like, it could be completely made up of gaze movements, or you could have more eye movements than touch input, or the other way around. But the point here basically is that the password consists of eye movements. And this is different in a way because it actually expands the password space a bit, because it incorporates new sets of password symbols. So now you don't only have digits from 0 to 9, but you also have eye movements, in this case here, left and right. So you have more options to make up your password, and this makes it more secure, or at least it makes the password space larger. On the downside, it might have a steeper learning curve because people are not used to, entering passwords using their eyes. And this is actually here an opportunity or a research opportunity for people who work in eye tracking in the wild, because most of the I say most, but let's say the vast majority actually, or like almost all of the studies that involved gaze-based authentication, they were done in the lab. And the reason they were done in the lab is that we didn't have the hardware that allows us to take these concepts to the wild, right? So we didn't have the hardware that we have nowadays, like mobile devices that can do accurate eye tracking. We didn't have those to allow people to use a method such as the one shown here for like 2 or 3 weeks in their daily lives. So we don't know how people actually select and recall gaze-based passwords. When you enter pins on a touch screen or a keypad, there is muscle memory involved. You start to remember how to enter your password. We don't know if this is if people also kind of have an equivalent of a muscle memory for their eye movements. So there are a lot of things that could be uncovered by doing an in the wild study of recalling gaze-based passwords in the wild, or selecting them or creating them and so on. And I know that today there are a lot of people also interested in VR, so I thought of bringing in a VR example, or an example of authentication using gaze in VR. What happens here is that a user enters a PIN in VR, and as you can see, if you look at this guy over here, you can see why this is a bad idea, because just from the movements you can tell that they're entering 1 because they're pointing at the top left, and then 9 because they're pointing at the bottom right, and so on. And now, luckily, many head-mounted displays that are used for VR and AR, they come with integrated eye trackers, and we're going to see more of those in the future as well. And this could be a nice way for authentication. So in this system over here, you are entering a password by looking at virtual objects in virtual reality and using this to authenticate, basically. A further way to categorize explicit authentication is based on the number of modalities involved. And so the typical thing is to use a single modality, or I mean, typical, but I mean let's say the initial attempts for gaze-based authentication, people looked into using eyes or gaze as the only modality for entering passwords, like the systems here. So IPIN responded to dwell time, and here you basically performed patterns using your eye movements. But then actually you could use eye gaze together with another input modality, like the example we saw earlier, actually. And there has been some work about that. There are very, very nice ways you can improve authentication schemes by combining multiple modalities. And eye gaze is particularly helpful here. So once you've built an authentication scheme using eye gaze, it's time to evaluate it, right? So usually you try to evaluate the usability and the security of the scheme. So when evaluating the usability, it's important to look into efficiency. So how fast do people enter passwords, efficacy, how many errors do they do, and also things like learnability and the user preference. It's very important to actually pay attention to usability because, if you have a more secure mechanism and you want to use it to replace an existing one, if the existing less secure method takes 1 second to like people who use it would need only 1 second to authenticate, but your more secure method takes 6 seconds instead, so 5 seconds more. Now 5 seconds of additional authentication time on your mobile phone, for example. By the way, you unlock your phone about 40 to 50 times a day. That's what research tells us. So if you actually unlock your phone 40 times a day and you introduced 5 seconds to each authentication attempt, then you've added 200 seconds a day. If you do the math, it'll be like 20 hours a year of authenticating. If you do this in a lifespan, or if you do this for 60 years, then you have spent 50 days of your life unlocking your phone 24/7. So it's really important to actually improve usability, because if you introduce a very secure method that no one can use or no one is willing to use, then you haven't, or people, or worse, even worse, people are misusing it, then security is eventually reduced. And then there's security, which you can evaluate as well. And one of the things you can evaluate is the password space. The theoretical password space of authentication method tells us how many passwords can be created using this scheme. But other than the theoretical password space, there is actually the practical password space, which is how much of the theoretical password space are people actually using. And this could be different, could be drastically different, actually. So actually, here is another research direction as well for people working in eye tracking in the wild, because again, as I said, we have not done in the wild studies of authentication using eye gaze. And by doing a study like that, we can then see which kind of passwords people create and infer what the practical password space is. So this is something that is not yet investigated and not yet known, and it would be an opportunity for future work. So I've spoken so far about authentication. There's also privacy protection, which I'll talk about briefly. So you can use eye gaze to protect privacy by building applications that are privacy aware. So for example, there are some applications about transferring content from public displays to personal devices And let's say you have a display in a public area that displays some news, and you want to grab some of this news and display it on your mobile phone, or just store it on your mobile phone. If you do this using eye gaze, then people around you are not aware of which articles you're interested in, for example, because people cannot easily map your eye movements to positions on the screen. So this was a paper from Kai 2018 where we compared eye gaze and touch and mid-air gestures to transfer content from the display to your phone. And people actually preferred the eye gaze method because it's private, right? Because people around them would not know which things they are interested in, which news articles or whatever they're grabbing from the screen, what are they interested in. You could also use eye gaze to do things like voting in public space, which allows you to vote, without, or select things without people around you figuring out what you've selected. So there is privacy and there is additional privacy in just using eye gaze as an interaction modality. And now this system over here called iSpot is also a way to protect privacy using eye gaze. What we did here is that we used an external eye tracker to tell where the user is looking on the screen of a mobile phone. And then we distorted the content around the point that the user is looking at. And this way, it limits the amount of information that bystanders have access to improve privacy a bit. And we've used it using an external eye tracker, but I think with today's phones, we can actually do this now using the front-facing camera of a mobile device. We have not done that, but I think it's now feasible. And the last category is improving security based on gaze behavior. And what I mean by this is actually just tracking the user's eye gaze behavior. You can understand things about their response to security indicators on websites. You can spot if they have looked at the URLs or the senders of emails before opening them, and this could help you in detecting phishing attacks, for example, or warning people about phishing attacks. You can also do things like, for example, now you can create picture-based passwords on Windows 10 and so on, and people tend to select the same points over and over different people tend to select the same points for their passwords. And there was this work by Bulling et al. That used saliency masks to determine which are the points that attract attention the most and prevent users from selecting these points, because these are the points that are more predictable to be used as parts of your password. So by doing this, you're improving security because people would then be forced to select more secure or unpredictable points for their password. And there has been a lot of work also by Cazzini et al. On creating user models for when people are creating passwords based on the eye movements, and using this to nudge them to create stronger passwords, or for example, detect or predicting which type of passwords they would create, and through their eye movements, whether predicting that they're strong or weak, and encouraging them in one direction or the other. So what are the main takeaways here? So gaze is very promising for security applications. There are applications of security in authentication and privacy protection, and in improving security based on gaze behavior. There's a lot to be done, especially in the last two areas, which are relatively under-investigated, which are privacy protection and improving of security based on gaze behavior. It's also now is the time to study gaze-based security applications in the wild. So this was not done in the past, and now we have the hardware and the computing power to do that, and algorithms and so on that allow us to do this. So there's a lot to explore, a lot to learn. This is what I mentioned earlier, that there is relatively less work on these two application areas, so we could do more there. And finally, what I brought up in the beginning is that the ubiquity of eye tracking can in itself be a threat to privacy, and this threat is relatively under-investigated. So, for example, we need to investigate if we can somehow ensure that gaze data that is collected through eye tracking apps cannot be used maliciously. So we are not able to do eye tracking on mobile devices, and we should actually ensure that in the future this is not maliciously used, either intentionally or unintentionally, by the users or by developers of mobile apps. So I encourage you all to join me in working in this area as well. Thank you very much, and I'm looking forward to the discussion session.